And welcome back. We are now going to dive into using typecasting and also coercion in order to get variables of a specific type to become a different type of variable. And we have seen a little of this already in play, but now let's go ahead and take a deeper dive. So the first thing we have to understand is that there is compatibility between the various different types of variables, specifically when we're looking at numeric types. So with those numeric types, recall that int and double are not necessarily compatible. All right, we either have to declare a variable as a int or we have to do as a double. And the same thing applies if we try to do a float or a long or anything like that. Now, when we perform arithmetic operations, we can only go between the two types if one of the two values in question is a double. Remember that two int operations will always be an int answer. And we already talked about how if I do an int and a double, it becomes a double, or if I do a double and double, it'll become a double. However, there is actually a way for us to kind of get around this. If let's say I want to do an int plus a double and I want it to be an integer, we do have a way to go ahead and kind of force Java to say, give me an integer. And that is using what's called typecasting. Now, typecasting is something that's built right into Java. All right, and let's look at this with a very simple expression here. Let's look at something like 9 over 2. If we evaluate this using int variables, so let's say I have an int, num1, and I set equal to 9, and int num2, and I set equal to 2, and I do the two divisions, well, we're going to get the value of 4, because remember, there is no decimal point. However, we may want the true value of 9 over 2, which is 4.5, and obviously we can use this using doubles very easily. And with these two variables, n equals 9, m equals 2, we have to do a little bit of math here. All right, so let's say we say double answer equals n double. This is called a typecast here. All right, the parentheses double is what actually is generating this into a double. Because if I do m divided by m, are we actually going to get the value we want? Well, this is a way to force Java to say, I want to have a double answer. Now, sometimes Java will automatically go ahead and convert these for us, which we will see. But here's a way to go ahead and say, like, hey, I want this to be specifically as a double. And again, as I mentioned, it is a way to force that value, in this case m, into a double, because if you notice, the parentheses is next to the m. Now, we could, of course, put that parentheses next to the n, and we could still get the same result. It's just a matter of where we want to put that. Now, where we are forcing it, that is called type coercion. There is a difference between Java doing it automatically, as we've known, because we can do an int plus a double, and we'll get a double. That's typecasting. But what we want to force it is type coercion. All right, because like I said, Java will typecast for us. All right, when we want to, let's say, change 5 into 5.0, we can say like double num equals 5 divided by 2.0. That is a way for Java to do it automatically. So that's type coercion. It's forcing that change. And Java will convert our things from int to double, but again, it won't work the other way. If I try to say like int I equals 5.5, it's going to come back with an error. But if I were to say like double num equals 5, we won't get an error because Java recognizes, oh, you actually put 5, but you mean 5.0. It doesn't know with the 5.5 how you want to handle that. Because do you want this to be int I equals 5? Do you want it to be int I equals 6? Which way do you want this to work? So it doesn't know what to do with this. However, we could do a typecast, and I could say int I equals parentheses int parentheses 5.5. And what that will do is it will change that integer into, or that double rather, into an integer that we can use for this variable. It was just like if we had gone and done this normally, and it just drops off whatever the decimal point is afterwards. Now, if we look at this with some examples here, I went ahead and created some simple code here. I have int num1 equals 3, num2 equals 4. I have a double, number 1 equals 3, number 2 equals 4.0. You notice here, I set this to a 3. All right, so if I were to test out this real quick before I run my program, I'm just going to go test out what does number 1 look like. So if I just put number 1 in here, we should, of course, this should say 3.0. Similarly, if I had a system.out.println of num1, that would just say 3, all right? And it's because it's automatically going to do that typecasting here for us. And if I were to add this, all right, num1 plus num2, well, those are both integers, so I would expect this to be an integer. number 1 plus number 2, I have 2 doubles. So again, I would expect that to be a double. And then I have num1 plus number 1. So that is a integer plus a double. And then I have num2 plus number 2, which again, because there's one double in there, I'm going to expect that to be a double. So let's go ahead and just run this real quick. And you can see that we get 3, which is what we expected. That's an integer. 3.0. Again, this is a double. And even though I put 3 here, Java automatically knows to convert that into 3.0. 7, because we got an integer. And then 7.0, 6.0, and 8.0, which again, because these are all doubles. Now, just to show an example of typecasting here, let's look at this one right here, num2 plus number 2. If I put in parentheses int, you'll see how it kind of makes it bold to say, I want you to make this into an integer. This should then convert this to basically say this is an int plus an int. And instead of seeing 8.0, I should now see the value 8. And sure enough, that's what we get. Now, what's if I want to do something similar here? What's if I want to typecast num1 plus number 2? Well, we could easily make this into a double here if we want. So instead of this saying 7, I could easily put a double here in parentheses. And you'll notice we will get 7.0 just as we expected before. So it's a real nice way for us to be able to kind of work around the different types here. This can come in real handy if we are, for example, some variables are set to one type and we have other variables we want to work with that are set to another type. Using the typecasting here in Coercion is a great way to get those different types to play nice with each other.